Welcome to General Chemistry Mini Lecture Series, Lecture 18, Balancing Chemical Equations. First, let's go through the guidelines for balancing chemical equations. When you balance a chemical equation, you need to change the coefficients. Never change the subscripts. Also, first, you should balance the elements that show up only once on both sides of the reaction. If you see three uncombined elements show up on either side of the equation, you should balance them last. Typically, oxygen molecules would fit this category. Also, you want to balance the elements that show up more than once on a side last. For polyatomic ions, you should consider them as a whole, as a single group. It's much easier to do that way. After you finish balancing the chemical reaction, you should check the number of atoms for each element on both sides. Make sure they are the same. And don't forget to indicate the states of matter for each reactant and product. Now let's balance a few chemical equations. So we'll start with a simple one, the burning of charcoal in the air. Carbon reacting with oxygen in the air, forming carbon dioxide. Let's take a look at the number of carbon atoms before the reaction, 1. After the reaction, also 1. The number of oxygen atoms before the reaction, 2. And after the reaction, also 2. So therefore, this equation is already balanced. Next, carbon disulfide once was manufactured by combining carbon and sulfur at high temperatures, and here is the reaction. Okay, so we can see carbon 1 on the left-hand side and also 1 on the right-hand side. So therefore, we just need to balance sulfur. On the right-hand side, we have 2 sulfur atoms. On the left-hand side, we need to change the coefficient for sulfur to 2. And now we can take a look at the carbon atoms before and after, the same number, and sulfur atoms before and after, the same number. So therefore now, this reaction, this equation, is already balanced. Reaction 3. Now consider the reaction of elemental hydrogen with elemental oxygen to produce water. So this is the formation of water. And if we look at the number of hydrogen atoms, it's already balanced. But that's not the case for oxygen atoms. So therefore, on the right-hand side, first we need to place a coefficient in front of H2O. That would give us 2 oxygen. Now, oxygen is balanced, but hydrogen is not. Hydrogen was balanced here, but it's not balanced in the second equation. So therefore, we need to take care of hydrogen now. Okay, so we place a coefficient of 2 in front of H2. And now let's count the number of atoms before and after the reaction. Hydrogen, 4 before and 4 after. Oxygen, 2 before and 2 after. So therefore, this yellow highlighted equation is already balanced now. This equation demonstrates the reaction of propane gas with oxygen forming carbon dioxide and water. So let's take a look at this equation. So the number of carbon atoms, there are 3 on the left-hand side, 3 carbon atoms on the left-hand side, but there's only 1 carbon atom on the right-hand side. So therefore, we should place a coefficient of 3 before CO2. So now, in the second equation, carbon is balanced. So the next one we need to balance is hydrogen. You see, oxygen, this is an uncombined element. You see, it's just by itself. So therefore, according to those guidelines, we normally should balance those elements last. Okay, so therefore next we are going to balance hydrogen. Okay, hydrogen, we have 8 on the left-hand side, and on the right-hand side, we have only 2. So if we place a coefficient of 4 before water, then now hydrogen is also balanced. So now let's take care of oxygen. Oxygen on the left-hand side, 2. On the right-hand side, we have 6 plus 4, that's 10. All right? So therefore, on the left-hand side, we need to take a coefficient of 5. And now, all of those elements, all of the 3 elements, they are balanced. And if you want to double check the number of atoms for each element, before and after the reaction, carbon, 3 before and after, hydrogen, 8 before and after, oxygen, before the reaction, 10, after, 10, 6 plus 4. So therefore, this yellow highlighted equation is balanced. Now let's balance a chemical reaction involving polyatomic ions. As we talked about just a while ago, for polyatomic ions, we need to consider them as a single group. So therefore, in this case, we just first replace SO2 with X. Okay, so therefore we can change the first equation to the second one. Okay, and now let's balance the number of X. So we have here 1 X, and here before the reaction we have 3. So therefore, before the reaction we need to add a coefficient of 3 here. That way we'll have 3X. Okay, now X is balanced. But let's take a look at oxygen now. We have 3 oxygen on the left-hand side, and we have only 1 oxygen on the right-hand side. So therefore, we need to change the coefficient for water from 1 to 3 on the right-hand side. So now you see X is balanced, and the number of hydrogen atoms, that's also balanced. Oxygen atoms, balanced. Great. Remember, we assume X equals SO4. Now we will get back. So we'll replace the X with SO4 with sulfate polyatomic ion. And this reaction should be already balanced. But let's double check. Okay, the number of iron atoms before and after, 2. Hydrogen before and after, 6 atoms. And then for oxygen, we just count for oxygen. We are not counting the number of oxygen atoms in the polyatomic ion. Okay, before the reaction, that's 3. After the reaction, that's also 3. Now the number of the polyatomic ion, so that's the sulfate. Before the reaction, we have 3, and after the reaction, we also have 3. So therefore, this reaction is already balanced. Now let's work on reaction 6. balance the chemical reaction of benzene reacting with oxygen. Okay, so take a look at the carbon. Before the reaction, 6 carbon atoms. After the reaction, only 1. Therefore, let's place a coefficient of 6 in front of carbon dioxide. Now carbon is balanced. So let's take a look at hydrogen. Before the reaction, 6 hydrogen atoms. After the reaction, that's only 2. So therefore, we need to place a coefficient of 3 before water molecule that make 6 hydrogen atoms. So therefore, now both carbon and hydrogen are balanced. But how about oxygen? Oxygen, before the reaction, only 2 atoms. After the reaction, that's already 12 plus 3, that's 15. So therefore, we need to add a coefficient of 7.5, make on the left-hand side. So that would make 15 oxygen atoms, and that equals the number of the oxygen atoms on the right-hand side. Are we done? Now all atoms are balanced. But are we done? Is this a valid chemical balance chemical reaction? No, because in a balanced chemical reaction, fractions or decimal numbers, they are not allowed. It has to be all whole number for those coefficients. How to make this 7.5 a whole number? Multiply by 2. But if this term is applied by 2, you have to do the same for all of the other terms. So therefore, for benzene, you should have a coefficient of 2. For oxygen, you should have a coefficient of 15. For carbon dioxide, 6 times 2, 12. Water, 6. And now, all atoms should be balanced, and all coefficients are whole numbers. If you want to double check, the number of carbon atoms before the reaction, 12. After the reaction, 12. Hydrogen before reaction, 12. After the reaction, 12. Number of oxygen atoms before the reaction, 30. After the reaction, 30 atoms. This is quiz question number 1 for lecture 18. Which side of coefficients balances the following equation? Ethane reacting with oxygen, forming carbon dioxide and water. Okay, let's take a look at this reaction. Before the reaction, there are 2 carbon atoms. After, 1. So let's first try place a coefficient of 2 in front of carbon dioxide. Now carbon is balanced. So next one, we are going to balance hydrogen. Before the reaction, 6 hydrogen atoms. After the reaction, 2. So we need a coefficient of 3 before water molecules. So now we have carbon and hydrogen balance. Let's take a look at oxygen. Before the reaction, 2 oxygen atoms. After the reaction, 4 plus 3, that's 7. How to make the total number of oxygen before the reaction to 7? Multiply by 3.5. So take coefficient of 3.5 for oxygen molecule. Now all atoms are balanced, but the problem is not all of the coefficients are in whole number. Multiply everything by 2. All of the coefficients by 2. So for ethane, the coefficient is 1, even though it's not written. So therefore, after multiplying by 2, we would have 2 ethane, 7 oxygen, 4 CO2, and 6 water molecules. And now, it's not only all atoms are balanced, but also all coefficients are whole numbers. So we can double check the number of atoms for carbon before and after. For the number of hydrogen atoms before and after, 12. and oxygen atoms before and after 14. So therefore, D should be the correct answer. The side of the coefficient 2746. 2746. And of course, you need to work on additional quiz questions and also your homework assignments. So this is lecture 18, and I will see you guys in lecture 19.